The first thing to tell you is that this Aurora alert is just 80 to 90% correct. The reason for that is that we have just a small amount of satellites in the space near Earth, which can actually track what the solar storm or the solar wind is doing right now at the moment. And also, we have no clue what is happening to the solar wind between the sun and the Earth. For that reason, it is impossible to catch every single Aurora event perfectly and correct. The first thing you see in the Aurora alert is that there is a traffic light kind of system to tell you what are the chances for any Aurora at your current location. In the top right corner, you can see your current detected location and the time the data inside of the Aurora alert was the last time updated. So instead of thinking and interpreting the values of the Aurora forecast by yourself, this just gives you a nice color display as a traffic light, which activity of Aurora you could expect at your location. The furthest down of the three indicators gives you a hint if there is Aurora possible at your location in the next 72 hours. This is especially useful if you are not living at the far north of this planet, because then it's not normal for you to have Aurora activity like every day when it's dark outside. The value is based on the forecasts made by NASA, so there's a problem that those forecasts are computer simulation of how the scientists think the solar storm or the other event coming from the sun to Earth will behave in the next 72 hours. So this is not a measured value, which is a big difference to the two other indicators. You can see that in the next 72 hours, it is said that the Aurora will be active. This means that there is a decent chance to see the Aurora in the next 72 hours at your location. If you want to know the exact time slot at which the Aurora activity is forecasted, you need to click on the View Details button. You can now see the exact event which triggered the Aurora alert to be marked as active. The dashed line you can see there works as a trigger. If there is an event which has a higher value than this calculated line, the Aurora alert will be triggered. The line is placed in respect to your current position. So if something reaches up to the dashed line or even cuts through it, this means that in this time slot there's a decent chance to have some Aurora activity in your place. So if you look closely, there are three possible time slots where there could be Aurora activity. Of course, you must now check if this is a time slot where the sky is dark at your location, because this forecast is universal for the northern hemisphere of the Earth, which means that it works in North America the same way as it works in Europe. The time is in UTC, which means you have to do a calculation to see what this time slot in UTC means for your local time at your location. This example is now for a further north latitude compared to the example from before. And now you can see that the dashed line went into another position in the diagram. You can see that it is now located between 2 and 3, which means if you go further north on the northern hemisphere, you need a less amount of a sunstorm or solar wind activity in order to see the Aurora at your location. And as you can see, this example is so far up north in the northern hemisphere of our planet that the Aurora activity is nearly reached every time slot for this particular location, which means that you can be outside every time in the northern hemisphere when it's dark outside and the sky is clear. Now we need to discuss a little bit the general behavior of Aurora. In this example, you can see two different types of Aurora. The one in the upper image is really weak. It has nice colors, as you can see, and many different colors, but it is particularly faint, and you could not really see the aurora in the upper image with your naked eye. It was so faint that it was easily as the same brightness as the Milky Way, even if it had all those nice red colors. And then sometimes the aurora gets so bright that the whole sky will be covered in green aurora activity. The major problem now is that there's only a weak correlation between the forecasted aurora activity and how strong a solar storm can be and the actual brightness and colorfulness of the aurora. What this means for you is that if you look at this example, you can see that there is a time slot with a forecasted KP value of 6 for a location so far up north that only a KP value of 2 is necessary to have aurora activity at this location. And one can now assume that this must be the aurora show of all time for this location because the forecasted value, the forecasted KP value, is so high. But the answer is yes, it can be that this will be a really good aurora show with a really good activity, but it doesn't have to. And other times the forecasted activity just reaches the breaking point of the dotted line you can see there, and you would assume that now the aurora itself has to be weak, but no, it can be that this is really colorful aurora in this case with really bright activity. So in conclusion, you can say that yes, when there is a stronger forecasted activity, the aurora itself can be brighter and more colorful. There's a small correlation for that, but you don't have to assume that the aurora is weak just because the forecast says that the KP value you can see here is not so strong. The only important thing with the forecast is if the aurora will be far enough into the south that you can see it from your position. In this example, you can now see that I'm in the center of Germany, which is talking about aurora and northern lights far away from the main area where normally all the aurora activity is located. This location results for the dashed line to be between a KP value of 5 and 6 because this is the least amount of a forecasted sunstorm we would need in this part of Germany so far south that there would be aurora activity visible from this location. Now I've put my location further to the north in the northern parts of Norway where the aurora is normally active like nearly every night. And now you can see that the dashed line moved between 2 and 3 for this specific location because this would be the least amount of aurora activity forecasted which you need to actually go out and try to get your luck. So what those values now actually present is not how strong and colorful and bright the aurora lights will be. It's more a forecast about how far south the aurora activity will be visible. Another important thing about the behavior of the northern lights is that they are not active all the time, even if the potential for northern lights is really high for your location right now. So the northern lights itself, they come in waves. It's called substorms. Those substorms cannot be forecasted. We only can say when they're happening right now. But, well, when there's a substorm, you will see it with your eyes because then there's a high activity of auroras in the sky. This means that even when you are outside and there's no activity of aurora right now, it can change within minutes and the sky can explode. So sometimes when you are outside, there is a chance that there is no aurora activity at all. Sometimes the activity is just weak, but then after a few minutes it can explode into this big event called a substorm explosion. Sometimes this can take hours of waiting time outside, because you are outside and you see that the potential for aurora is really good right now, but there is no activity and there's nothing you can do about it. The most important thing is to just wait outside if there is activity forecasted. And this brings us directly to the next value, which is called the current potential. Current potential answers your question if you should be outside at your photo location right now and be waiting for the aurora. And this is the big difference between VIEWFINDR and all the other aurora applications, because they just tend to happen to tell you when there is aurora right now. But well, when there are northern lights right now and you are outside, you can see them. So the idea of this is to send you outside in the right moment and to make you stay outside as long as there is potential for aurora activity at your location. For areas high up in the north, like Alaska, Norway, or Sweden, this is trivial because most of the time there is aurora activity and aurora potential in the night. But further south, like North Dakota or Denmark or UK, it can be that there is aurora potential only sometimes. And you want to know if sometimes is right now and if you should be outside waiting for aurora activity. So yes, if you just want to know if you should be outside at your location right now and be waiting, then this is the parameter you just have to look after. Right here in the example, it says weak, so there's no reason to be outside. So in the next example, it says active. This means that right now you should be outside at your location because, well, the naming and the colors, they are just rule of thumb. So active is like the middle of it, and with active, this is where I personally would be outside because I know how I made the algorithms for this, and yeah, there's a reason I say with active, I will be outside and waiting. The next example, you can see that the current potential is said to be extreme. Well, this just means that at your location, there is enough energy in the magnetosphere or in the solar wind right now, which could bring a good aurora show and good visible aurora at your location. It does not give you information about how bright or colorful the aurora will be. It just says that you have an extreme high chance to have auroras at your location sometimes in the next hours. And please remind yourself that this is just a potential. It means that there can be aurora, but it doesn't necessarily have to be. So you can have a high potential for auroras over hours and hours with no aurora activity. The top parameter says expected activity. This is the short-term forecast, which gives you an idea what will happen in the next 60 minutes at your location of aurora activity. And yes, also another disclaimer for that, we just have a small idea what actually is happening right now in the magnetosphere of the Earth. So even if the expected activity for the next hour is said to be like strong or extreme, it can happen that it's still not active. Okay, it won't happen often, but it can happen. And as long as the current potential is high, the only thing you can do is just to be outside and be waiting. So as a summary, you can say that the lower parameter is for the question, can I expect aurora in the next 72 hours at my current location? The middle one answers the question, should you be outside right now waiting at your location, because the potential for aurora at your location is really high. And then the expected activity just tells you if you should be ready to capture photos of the aurora right now. Further down, you can see more values related to the aurora. Well, I will not explain in the tutorial what those values exactly mean, because this would be too much to explain in this short video tutorial. And so if you want to have more details about this, you can just go online and search for the values. We added them in because there are some really Aurora geeks using this application, hopefully, and they know how to handle those values. So for you to better understand what the values mean, we put those values in a specific color. So if those values are in favor for aurora at your current position, we will just color them red.